Hello everyone, this video covers participation number 4 for college algebra. The question is asking you to find all the solutions to this polynomial. Now, you are actually supposed to solve this using synthetic division and factoring, but if you just want to use factoring to solve the problem, that's perfectly okay too. The issue is that sometimes you cannot factor the problem, and therefore synthetic division is going to be better. And besides, synthetic division is going to be very useful if you decide to go into the extend measures. Okay, so first I'm going to do it the long way and then the easy way. So the possible solutions, okay, are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Remember, the possible solutions are the factors of this number. Then we use a synthetic division. So we have 1, -3, -4, and 12. And remember, the goal is to get 0. So let's start with the easiest one, which is the number 1. So then this goes down, so this is 1. And then this one just goes down. 1 times 1 is 1. This is -2. Now -2 times 2 times 1 is -2. You add it up, so this gives you -6. -6 times 1 is -6. And this is equals to 6, which is not 0, so therefore the 1 doesn't work. Alright, so let's try one more. Again, synthetic division is annoying, but it's going to be one of your best friends later. And maybe not in this class, but you decide to go into the extend measures. So let's say this is 1. Let's try now 2. So therefore this will be 1. You just bring it down. Then 1 times 2 will give you 2. So this is -1. Then -1 times 2 is -2. So this is -6. And then -6 times 2 is -12. And this gives you 0. And that's great. So therefore from here, since we get 0, that means the x cubed minus 3x squared minus 4x plus 12 can be factored as x minus 2, because we already know if x is a root, so 2 minus 2 is 0, times this will give you now x squared minus x minus 6. This is x squared minus x minus 6. And obviously, this one is easy to factor. This will be x minus 3 and x plus 2. So therefore, the solutions are x equals to 2, 3, and -2. Again, if you don't do it this way, it's not a big deal. I'm just telling you this is the method that you were supposed to learn in this section, or I mean in this chapter. But if you did it this way, it's perfectly fine. Or you can just factor straight out like this. So you have x cubed minus 3x squared minus 4x plus 12. So if this is equals to 0, you can factor by grouping. So you factor this 2, then this 2. The factor for the first one is x squared, and then this is x minus 3. The GCF for the second part is 4. This is x minus 3. This is equals to 0. So then this will be x minus 3 times x squared minus 4. So this is x minus 3, x squared this will be x minus 2, x plus 2, and therefore the solutions will be 3, 2, and negative 2. And again, this is perfectly fine, so you can just do it this way. The only thing you have to be very careful, okay? If you have something that will look like this, like x to the 4 minus 3x cubed minus x squared plus x minus 6, something like this, then the factoring method is not going to work because grouping doesn't work here. So then you will have no choice but to do it this way, okay? But in the exam, you probably will have a question that is like this, so you can probably do it either way. It's up to you. All right, so let's go to number 2. Again, notice the ln of e to the negative 4 is the same thing as negative 4 ln e, but ln e is just 1, so this is negative 4. All right, so therefore on the right side we have negative 4 plus 4, which is just 0. Now the left side, by the properties of logs, this is equals to ln of 6x plus 3 divided by 15x minus 5, and this should equals to 0. Then if we change to exponential, this will be e to the 0 is equals to 6x plus 3 divided by 15x minus 5. But remember, anything to the 0 power is equals to 1. So therefore from here we have that 15x minus 9 is equals to this part. Then if you solve for x, subtract 6x and add 5, so this will give you 9x is equals to 8. So that means that x is equals to 8 over 9. Now notice that in this case, since the right side is equals to 0, you have technically ln of 6x plus 3 minus ln of 15x minus 5 is equals to 0. So you pretty much could say that ln of 6x plus 3 is equals to ln of 15x minus 5. And you can cancel the ln, and then you will end up with 6x plus 3 is equals to 15x minus 5, which is technically this right here, okay? So there was no need to do it this way. However, it is when that equals to 0, this is the proper way to do it. So this is how you should do it. Just write it as a single log first, then change to exponent, and then solve for x. All right, so now let's go to part B. And in part B, this is what we have. We have log 2 of x squared is equals to 10 log 2 of x. Why is this the case? Remember recall that you have a log b of x to the r power is equals to r log b of x. These properties of logs are also very, very important if you want to study calculus, pre-calculus, and stuff like that. Now, the way this is, the equation looks pretty weird, and you can solve it straight from there. But it will be easier to make a small substitution like this. So let y equals to log 2 of x. So if that's the case, that means that we're going to have now y squared is equals to 10y. And you can see right away that this looks much friendlier. So how do you solve this? Just set it equals to 0 and factor. You will have y times y minus 10 equals to 0. So the two solutions will be y is equals to 0 or y is equals to 10. But remember, we're trying to find x, not y. But remember that y was defined to be log 2 of x. So therefore, this implies that log 2 of x has to be 0. And this one, that log 2 of x has to be 10. If you change from log to exponent, that means that 2 to the 0 is equals to x, or 1 is equals to x. That's the first answer. Here, if you change from log to exponent, it will be 2 to the 10 is equals to x. And this is an acceptable answer, or 2 to the 10 is 1024. So either one is fine. And that's it for number 2, part B. Okay, number 3, we're going to do a composition of functions. So first, notice that this just means f of g. Now, this looks messy, and it could be messy, but this is actually pretty simple. If I were to ask you to find f of 3, then this will be 2 times 3 squared plus 5 times 3 plus 4, and then you simplify. If I were to ask you to find f of h, then this will be 2h squared plus 5h plus 4. You cannot simplify this anymore because you don't know what's the value for h. So this is kind of what we're going to do. So therefore, this will be equals to 2 g squared plus 5g plus 4. If we follow this part right here. Now here we don't know what h is, but here we do know what g is. G is equals to this. So therefore it will be 2 times 2x plus 4 over 4x minus 5 squared plus 5g, which is 2x plus 4 over 4x minus 5, and then plus 4. And there is no need to simplify anymore. So therefore this is 2g squared plus 5g again plus 4. And you can just leave the answer like this. Okay, so once you get to this point, you're done for this problem. All right, part B is asking you to find the inverse of g. And here g of x is equals to 2x plus 4 over 4x minus 5. Now to find the inverse is straightforward. You just have to be careful with the algebra. So step 1, just write it like this. Y is going to be 2x plus 4 over 4x minus 5. So pretty much just replace x for y. Or in step 1, you can say y is equals to gx. Okay. Now step 2, you're going to switch x and y. So wherever there is an x, put a y, and wherever there is a y, put an x. So therefore, we will have x is equals to 2y plus 4 divided by 4x minus 5. 4y minus 5. Okay, so it should be 4y minus 5. So far this is pretty straightforward. Step 3 is the one that takes all the work. So this one, solve for y. So how do we solve for y? Well, first you cross multiply. So you cross multiply, you're going to have x times 4y minus 5 is equals to 2y plus 4. So you just cross multiply. Okay. Then you're trying to solve for y, so this 3, so this will give you 4xy minus 5x equals to 2y plus 4. Then put the y's in one side and move everything else to the other side. Okay. Then from here, you can factor y, so this will be 4x minus 2, and the other side is 5x plus 4. So to solve for y, you divide by 4x minus 2, so y will be 5x plus 4 divided by 4x minus 2. So therefore the inverse will be exactly what you got here. So this is 5x plus 4 over 4x minus 2. I mean, if you want, you could call this a step 4, but there's no need to have too many steps. 3 is enough. All right, part C is asking find the domain and range of G. So G is missing. So remember, G is equals to this. So the domain is only will have an issue if you divide by 0. So therefore, for the domain, 4x minus 5 is equals to 0. That means that 4x equals to 5, or x equals to 5 over 4. Therefore, that implies that the domain is x is not equals to 5/4. So you can say it's all the real numbers except for this. If you want to write it in interval notation, this will be minus infinity to 5/4 or 5/4 to infinity. But this is good enough. Now the range is a little more tricky, but if you remember from the inverse functions, if you have f, so note in case you didn't catch this anywhere in the lectures, if you have f and f inverse, every function has a domain and has a range. So say domain and range. So it also has a domain and has a range. Now this is only true for the functions that have an inverse. The domain of the function is the range of the inverse, and the domain of the inverse is the range of the function. Okay, so this is very important. Now here where we have the inverse, so therefore the domain of this one is going to be the range of this one. And from here, you can see that the domain of f inverse, you can tell right away that it will be x cannot be 1/2. Okay? Why? Because you have for x minus 2 is equals to 0, or for x equals to 2, or x equals to 2/4, which is 1/2. So therefore the range, you can say all real numbers except for y equals to 1/2, or you can just simply write y is not equals to 1/2, or you can use the interval notation minus infinity to 1/2 or 1/2 to infinity. Okay, either way is fine. Now here is very important to realize that without the inverse, it will be very hard to figure out what the range of this function is. All right, so now let's go to number 4. So this has to do with exponents. So this says the half-life of carborex is 20,000 years. If you buy 1.5 kilograms, how long will it take to decay to 800 grams? Now, there are two ways you can do this. You can just use the half-life formula, or you can do this from scratch. Remember, the equation is equals to this, okay? Where y0 is the initial amount. So y0 in our case is equals to 1.25 kilograms, which is equals to 1250 grams. Okay. So therefore, it says that the half-life is 20,000 years. So therefore, from here you have the 1/2 of y0 is equals to y0, and it should be e to the r times 20,000, because that's how long it takes to get to the half-life. So that means that in 20,000 years, you will end up with half of what you have. Okay? So then clearly this one cancels, and you have e to the r times 20,000, or you can say 20,000 r is equals to 1/2. Now we change from log to exponent. This will mean the 20,000 r is equals to ln of 1/2. Okay, so from here we have that r is equals to ln of 1/2. ln of 1/2, you use a calculator, is around minus 0.693115. That's enough digits. So this will be minus 0.69315 divided by 20,000. And this is equals to negative 0.000347. So once we find the rate, then you can find anything you want from this equation. So from here then, it's telling you how long it's going to take to decay to 800 milligrams. So now you want 800 should be equals to the initial amount, e to the minus 0.000347 t. Alright, so from here, then we have you divide 800 over 1250. You get 0.64 on the left side, and on the right side you have e to the minus 0.0000. Be careful with the zeros t. So then you change from log to exponent, you're gonna have the ln of 0.64 is gonna be equals to minus 0.000347 t. So that means that t will be equals to ln of 0.64 divided by this, and this is around 12,862 years. Okay. Now you should check to see if the answer makes sense. This is what I mean by makes sense. The half-life is 20,000 years. So that means that it takes 20,000 years to decay to half of the original amount. If the original amount is 1250, half of that is going to be 625. So therefore, in 20,000 years, you will have 625. Since you want 800 is more than half, so therefore it should take less than 20,000 years, which it is. It's 12,862. So the answer makes sense.